Welcome, and thank you for joining us today to discuss how we are working on predicting employee burnout at scale at Ceridian for ourselves and our clients. My friends in legal wanted me to pop this up quick, so a little eye chart for you. This is just a quick legal disclaimer. We will be talking about some things that are not yet available in our product, and know that everything we talk about is accurate as we know it today, but sometimes things change with deadlines and features as we roll out, and so things may look different when they roll out to the masses. So my name is Brittany, and I'm an organizational psychologist and executive coach for Ceridian. And at Ceridian, I work on applying psychological theories to the workplace to help our clients to improve their workforce.
Hi, my name is Sang. I'm a data scientist for Ceridian. I work on applying data science techniques to solve business problems at scale.
Hey everyone, my name is Shyam. I'm a senior data scientist working for Ceridian. I primarily work on securing data sets, designing and developing ML architecture to enable responsible development of AI.
And if you're not familiar with Ceridian, Ceridian is an HCM software company. And today we are going to talk to you about how we use our data to conduct research projects by walking you through the process of our most recent study on employee burnout, highlighting where and how we use data science in our process. So we'll start off by walking you through the process and helping you understand what is burnout, how we're measuring it, what we did to protect our data by de-identifying it, the feature engineering, feature selection, and we'll have a ton of time at the end for questions. So if you could, please hold your questions to the end and we'll definitely have time to get to it. So our study process. Our studies start off with an NLP tool that our peer created to listen to what is being talked about in the media and popular sites related to our industry. We then track these themes over time. This tool informs our studies by helping us prioritize what will be important for our organization or our clients. And then I look through the academic literature to see what studies have been done and how they are defining and measuring. The academic literature gives me a nice solid foundation on which to continue the research. I then look at the data that we have available to us, and we have a large system with a lot of different modules and a lot of different data. And in there, I find attributes that I can use to measure and attributes that I can use to validate. And I analyze where the data is today. And then I pass it over to Sang and Shan to work on predictive models. And they will talk more about their part later in the presentation. And for the final step of ACT, I use what I learned in the literature review to write up actions organizations can take to help improve things like burnout. So it doesn't do us a lot of good to just say, here's where your organization is. It's that ACT piece that will really help improve the workforce. So here's what this process looked like for our study on burnout. In 2022, we saw the topic of burnout explode in the popular media. You couldn't look at a news source without seeing an article on burnout, and our NLP tracking on topics over time picked up on this. But why did it explode? And what is burnout? So I often see burnout discussed only from an exhaustion factor, but exhaustion is not the only factor that leads to burnout. This matters because it's like the difference between talking about feeling nervous and having an anxiety diagnosis. And burnout is a psychological syndrome that is recognized by the World Health Organization, and it is defined as a response to chronic interpersonal stressors on the job or in your personal life. And it actually consists of 3 components. The exhaustion, which is what people are most familiar with, and that's feelings of energy depletion, being tired. The next one is cynicism, and that's an increase defined as an increased mental distance from one's job or feelings of negativity towards your organization or your role. And the third one is efficacy, or a declining sense of professional capability. And for efficacy, I like to point out that this can be real, where the people around you are saying your work is not as good as it once was, or perceived that you don't feel like you're living up to your potential or the quality of work that you can produce. And when measured properly, academic research reports that only 10 to 15% of employees fit the true burnout profile. And I'll note that that study that I'm citing there was done pre-COVID, though I'm seeing that burnout seems to have peaked for organizations in 2020 and has been trending back downward to pre-COVID levels since. And when we talk about burnout, burnout is one end of what I call the broader categories of work energy. And so 10 to 15% of employees fall into burnout, but usually 30% of an organization falls into the engaged category. And so that leaves over half of employees to fall somewhere between engaged and burned out. And academic literature tells us that if someone hits a true burnout, the only way to improve it is a change in job environment. And so this can be your role, leader, job tasks, or changing companies. So what causes burnout? The top causes of burnout are unrealistic deadlines or results expectations, consistently working long hours or on weekends, and I'd add to this that unpredictable schedules are a big part of this too. So I think a lot about healthcare workers, where maybe on Monday you're working AMs and Tuesday you're working PMs, and maybe this week you have Wednesday off, but next week you don't have Wednesday off, and it makes it really difficult to plan your personal life or commit to things that are important to you to uphold your values. Other causes are a lack of job clarity, a lack of control, dysfunctional workplace dynamics or unfair treatment, lack of social support, and lack of workplace communication. And I'll call out on that unfair treatment when I'm talking to managers. The manager doesn't have to agree. As long as the employee feels that they are receiving unfair treatment, that can lead to burnout. That is what is important. So knowing what burnout is and common causes of burnout, why is burnout important for people and organizations? Burnout is important because it's a costly problem for organizations and people's general well-being. Burnout accounts for 1/3 of all voluntary turnover, and a Stanford study found the psychological and physical problems associated with burnout employees cost an estimated $190 billion a year in healthcare spending in the US alone. And someone experiencing burnout is 23% more likely to visit the emergency room. And burnout causes a significant loss of productivity, estimating to steal 1 to 2 hours per burned out employee per day. It is also estimated that 50 to 60% of absenteeism is due to the psychological consequences of burnout. As burned out employees are 63% more likely to take a sick day than those who are not. And I think most importantly, it's important because workplace stress is the 5th leading cause of death in the United States. It's attributed to causing 120,000 deaths each year, which is higher than Alzheimer's or kidney disease. So if you're concerned when your coworker comes to you and says, "I have kidney disease," you should also be concerned when your coworker comes to you and says, "I'm stressed from work," because this has real physical and psychological consequences. And by understanding how to measure it, we can start to get to action to reduce some of those consequences. And this project is impactful to work on because this is a project that can truly improve lives. So let's dive more into how we are measuring burnout. This is burnout mapped into its 3 categories against the other work energy models. So you can see here the components of exhaustion, cynicism, and efficacy, and the high and low flags. So here you see that burnout is high in exhaustion, high in cynicism, and low in efficacy. You can also see the categories of the other combinations of highs and lows. And the bottom 3 in the black box are highlighted because these are not found in the academic literature. These are 3 new ones that we found when doing our studies. And this mismatch is likely because in the academic literature, the gold standard for measuring burnout is a self-report survey. And instead, what we are looking at is what actually happened. We're looking at the real data in their HCM software. So this is important because think about it like this. How many of you have ever said, I want to lose 5 pounds? But did you actually set goals and milestones to achieve that? Or for employee engagement, a common one I see is someone who answers the question, I would like to be working here 1 year from now, with a strongly disagree 5 years in a row. So they don't want to work at the company anymore, but they're doing nothing to change it. And so they're staying. That difference in what we want to do and what we actually do is why we likely found the additional combinations. And I won't go deep into each of the definitions of the other work energies in the discussion today, since we're focusing on our burnout study, but I include them so that you can see how they compare and see that there are different types of burnout. And these different types are important because they give us more nuanced detail to recommend actions. And I do like to quickly talk about the burned out manager didn't notice. One, because it generally makes people chuckle when they see that title. Maybe not my most creative titling. Marketing will help me with that. But to be fair to managers, they may have noticed, but they are still saying that this person is still the best person on my team. I'm giving them the highest performance rating, the biggest bonus, the most stock options, whatever I can do to retain them. And so during this project, I talked to a woman that fell into this category about her experience. And she gave the example. She said, I'm so overwhelmed. I'm so stressed out. We're so under-resourced. I'm being asked to do so much. But every time I go to my boss and I start crying in their office, they give me more money. And so now I make so much money, I feel like I shouldn't go somewhere else because I'd be taking such a large pay cut. And I don't know if I can do that to my family. So I feel trapped. That's more of what's going on in that category. So let's talk more about our data sources. Here are the different parts of our system. We have human resources, talent intelligence, which is recruiting, candidate data, workforce management, people analytics is our reporting, people experience is like succession planning, talent planning, performance management, goal setting, people engagement, we have a survey platform, and payroll. So these are just some of the sources of data that we can look for when we're trying to define how we're measuring it. So knowing the definition of burnout, the symptoms and the causes, we take those pieces and we look across this entire holistic platform to create a flag for each of the components of burnout. One for exhaustion, are you high or low? One for cynicism, are you high or low? And one for efficacy, are you high or low? And this enables us to measure who is currently burned out. And from there, then we can train a model to predict who will burn out in the future. And we can send messages with suggestions to managers for what they should do to prevent their employees from burning out. And in order to do this research, we have obtained permission from a subset of our clients to use their data for research purposes. And then we de-identify that data for us to safely work with it. And Shan will go into more details about how we de-identify the data.
Thanks, Brittany. With the ever-growing list of data privacy laws such as GDPR, HIPAA, and CCPA, and almost 1,400 publicly disclosed customer data set breaches just in the year of 2022, we at Ceridian clearly understood the necessity to protect customer privacy when trying to measure sensitive measures such as burnout. So instead of anonymizing the data and throwing all the analytical value out of it, we created an in-house de-identification technique to secure the data set, and we used it in this exercise. The main purpose of de-identification approach that we have come up with is to strike an analytical balance between an analytical value and the security of the data by identifying and transforming the PII in the dataset. We established this balance by segregating our PIIs into direct and indirect identifiers and transforming them accordingly. So the following slide will explained the necessity to pick up both direct and indirect identifiers more clearly. So in this example, as you can see, our algorithm has done a pretty good job in picking out direct identifiers such as an employee's name, his ID, his date of birth, and his zip code, and things like that. So let's take, for example, Jon Snow. Have we done enough just by masking or identifying these direct identifiers? That's a very good question, but let's look at those columns which are flagged as indirect identifiers to answer that question. For example, the indirect identifiers such as position, state, and gender. So senior database administrator who is from Ontario and who is a male. And apparently, Jon Snow is the only person who matches that criteria. So with just some extra information about a person and few other information from direct indirect identifiers, a person would be able to zero in on a particular employee, and that would cause a breach of privacy. So we made sure our process picks up both direct and indirect identifiers, and we treat them accordingly. And once this de-identification process is done, we move over to predicting burnout.
Well, thank you, Shan. Now that we talked a bit about how we're securing our customers' data, the next challenge is to apply data science techniques to the problem. And today I just want to share with everyone here our end-to-end journey of applying data science to solving this problem. So at a high level, we have this very wide de-identified data set with data from payroll, HR, people analytics, and so on. And we also have some burnout data. Our initial thought process was, what if we apply feature selection to this data set? Then we can find the relevant features for predicting employee burnout. And the end goal of this is to create a lookalike model to find more features so we can leverage those very same features, but for all of our clients. So in other words, what if we set this de-identified data set as matrix X, where the columns are features 1, 2, 3, and 4, etc. And what if the employee is burnt out as vector Y? This seems like a simple problem, right? Simply plug into one of the existing ML libraries, such as scikit-learn, find all the relevant features, and then do a feature selection on it, right? Simple plug and play, right? Well, it turns out the reality of the data is much different from what we hoped it would be. In our subset of data, we have about 1,500 plus clients, and each one of those clients have their own tables. And they all have about 5,000 plus tables, each with their own columns. So in other words, the data set is way too wide, and it needs to have some kind of transformation before we can apply feature selection. And furthermore, we also had to structure the data in a way where it makes sense to apply a model at all. So the challenge then becomes, how do we solve this problem at scale? Now that we define the problem, the next thing is we had to worry about was the computational costs. Going through 1,500 plus clients, 5,000 tables, it's about 7.5 million jobs. This can get really, really costly, even if a job took about a minute each. So we had to narrow down the data a bit before even doing any data science at all. We know that a lot of our tables are reference tables or ID tables, tables that are not super useful for prediction. So for those tables, we use the regex filter to remove them. And on top of that, we also went through the tables, some of the tables manually to filter the data down to about 100-ish tables. And even narrowing down the tables down to about 100, we still had a fairly wide data set with 1,500 plus clients. So what's next is we needed a way to store all these employee and client profiles and their features. And for that, we went with Databricks and Spark to do the heavy lifting of transforming the data. The output of that is a single table that's very long and very narrow with billions of rows. And the idea behind this is that the Spark architecture allows us to very easily query the table to extract whatever data that we need for any client or feature. Also, Spark has this function called Pandas UDFs, which allows us to run these table and client combinations in parallel. And also, this allows us to leverage the power of parallelization in Spark without needing to code too much in Spark. So we can stick with mostly writing Pandas code. And I just want to give everyone a bit more insights about what's going behind the scenes with Pandas UDFs and how we're parallelizing the workload. Specifically, I want to talk about the group map function. Essentially, we can write our code in Pandas to do whatever we need. And the group map function allows us to transform any Spark data frame input to Spark data frame output. So what we've done here is we can scan through each client table, read it into Spark as one big table, and then use the group map function to partition the data out. So in our case, our partitioning process is going to use client ID as the group by. And then each one of these data partitions are going to be a client/table combination. And they all get converted into a Pandas data frame where we can process each one individually in memory. So what we're essentially doing is we're breaking down this large data set into smaller chunks of data and then running all these jobs in parallel. And after a job runs on Pandas, it gets converted back into Spark where then the tables are concatenated. And this process gets repeated many, many times for each unique table. But note that the output schema is always going to stay the same. So even if the input tables are different, as long as the output table stays the same, everything gets combined together. So what we've done here is we designed a single table to store all of our features. That way we can easily point to any target variable y to this singular table. And again, in our case, our target variable y is the burnout vector, which is whether if the person is burnt out or not. And to give everybody an example in code, say example, we have a UDF written in Pandas here. We'll call it feature engineering UDF. And all this function does is take any Pandas data frame as an input. It does an aggregation on all the columns with the mean. And then it does a melt operation to transform the table to a vertical format. The output of that is another Pandas data frame. And then next, we can define an output schema structure. In our case, the output schema structure is the client ID, the feature name, and the feature value. We can do a group by on the client ID on the Spark data frame, and then apply the function that we just demonstrated earlier in Pandas. So unfortunately, I can't show any real data, but what this is essentially doing is again, it's splitting out these different client ID data partitions, converting them into Pandas, and then outputting them in Spark, and then concatenate all these data frames together. Okay, so now we've created a whole bunch of features for all of our tables. We had to narrow down the features to a smaller set of useful features. And to do that, we can split the data set into a training and testing set. So we put random clients in the training bucket, some in the testing bucket. Training bucket goes through the feature selection process, and from that we can create classification models to test against the clients in the testing bucket. So at this point, it's really close to being a bread and butter classification model where we can evaluate the results. However, there's still a few more caveats. Similar to feature engineering, we still have to apply the same principles to parallel our jobs because we're still dealing with a very large table that we can't simply load all into memory, right? And we can't load billions of rows into memory. So again, we utilized Spark, Pandas UDFs, where we did the group by on the table, source table name specifically. This will create many partitions for the worker nodes on Databricks to process. And then we can run the feature selection algorithm in Pandas and Python on each one of these data frame chunks. And then finally, we get the output with the resulting features from each one of these chunks. And then they all get concatenated together into a more narrow set of features that is more suitable for any type of ML algorithm. So at this point, now is pretty much a standard classification model. I won't go in too much detail, but we've used MLflow to run different experiments, and then we tuned their hyperparameters and documented their metrics. The table you're seeing here is the results that we had using a sample data set of about 10 clients as a POC before taking the whole process I've outlined today to production. And the results of this POC uses a logistic regression model. From there, we can check the F-score, position, false positive rate, or whatever metrics you want to throw at it. In our case of predicting burnout, we wanted to minimize the false positive rate because it takes time and resources to take an action on an employee that we've labeled as a positive. And we're already seeing pretty decent results with our limited data set that we use for our POC. And for this model, we got a precision of about 0.711 and an F-score of about 0.65. And our false positive rate is 0.174. And as we add more and more data to this model, we expect all these results to improve.
So once Seng has done her work and the ML model has categorized someone's work energy, then I can build visualizations to report this data back to the key stakeholders. So on this slide and the next is a mock dashboard of what a visualized report back to a key stakeholder could look like. It is not based on real data. And here you can select in the calendar dropdown for the time period you want to look at. You can see what % of your employees are high in exhaustion, high in cynicism, and low in efficacy, since those are the 3 combination flags that would be indicative of burnout. And then in the colored heat map is what % of your workforce is in each work energy category. And the following 3, burned out by department, burnout over time, and burnout by location, are just your % that are in the burnout categories. And the burnout categories are separated because they allow us more nuance to recommend actions. And I'll show you on a later slide, we can recommend some actions within this visualization, which is why we keep them separate versus just having a burned out category. And some of the key findings that we have found in the organizations that we've studied. So in our first industry study, we found that in the beginning of 2022, approximately 20% of the employees in supermarket, hotel, and were experiencing burnout. And you may ask why we honed in on those industries. And honestly, it was because that's where we had the most amount of data available to us versus other industries. We also found that hourly employees were less likely to be burned out than salaried employees. And this is likely because hourly employees can set better boundaries. Not every organization wants to pay an employee overtime. So the hourly employee can say, I'm at the number of hours I'm contracted to work. I'm not going to take on any more. Whereas a salaried employee may be being asked to do more to fill in some of the gaps. Salaried men in supermarkets and hotels were 40% more likely to be burned out than salaried women. And we found that burnout increases with tenure in the supermarket and hotel industry, and starting with almost no burnout in that less than 12 months tenure. And that really helps validate the academic finding that a change in role or a change in organization can be really helpful to resetting your work energy and moving you out of the burned out work energy category. But then we see burnout jump up to 22% in the 12 to 24 months, and then it sharply decreases to 12% in the 2 to 5 years. So an interesting thing about the 12 to 24 month tenure time period is that I hear from recruiters that is the easiest time period for them to recruit employees away from an organization. So they target employees that are in that 12 to 24 month tenure category. So what I believe is happening there, my hypothesis, is that you have people who have spent 12 months in their role and they've been able to gather enough data to say, is this role right for me? Is this organization right for me? And if not, I need to start looking. And at the same time, you have recruiters going, I'm going to cold contact more people in this tenure category so that I can recruit them away because they're more likely to be easier to recruit away. So you have both of these factors working in tandem there. So in that decrease in burnout, you have the people who likely burned out early have left the organization, or at least a large chunk of them. And so then we look at tenure and it steadily increases in every category up to the 35 years of tenure with an organization. And that's likely then it starts going down again. And that's likely because we start seeing retirements there or people stepping back to take smaller roles as they transition into the later half of their life. So key stakeholders can look at these visualizations and start to understand the story of their organization. When we met with stakeholders to get ideas for what would be most helpful, they did say the employee level information. So in all of these visuals, you can drill through to see this more detailed view. And this view gives them a more detailed way to dig in and formulate the action plan. So a manager can dig in and say, I have 3 that are engaged and 2 that are disengaged. What do I need to do? The nice thing about employee motivation or employee engagement is that while you can do things incorrectly, like if you incorrectly recognize someone, you could demotivate them. But for the most part, setting clear boundaries for people, monitoring their workload, setting clear goals will always help engagement. And then we want to get organizations to action. I talked earlier, it doesn't do us a lot of good to tell people what's going on in their organization if they're not going to do anything about it or don't know what to do about it. So we want to get them to the act stage. And to enable organizations to act, we can feed them alerts and recommendations of when to take action and what actions to take. So if you notice here, and sorry, it might be a little small on your screen, we have these nudges. And the turnover rate is currently highlighted in red, but we could also put the burnout rate in here and have it email you when it goes above or below a certain threshold. And the image in the bottom corner is embedding actions into the visualized reports like I showed you on the last two slides. And so here you can see we highlighted our high cynicism is over our goal. So I highlight this question mark and it gives me 3 ideas of things I can do to start reducing this number. So the other thing we can do with this is we can embed links. And so we can point people to our Knowledge Center for more detailed information on things like recognition exercises, since recognition is important, but it is an example of where if you do it incorrectly, it can demotivate people. So we can alert them that they hit their threshold, we can give them some general ideas, and then we can link them to more detailed information of exercises they can do to dive in deeper with their team. So where are we going? What we want to do next is continue testing those actions and validating that they can work in real life scenarios and outside of academic labs. And some use cases. So one thing we're really curious to answer is there anything else that moves someone out of a burnout work energy? We talked about that a change in job, a change in roles, a change in leader, a change in organization, but is there anything else? We also want to understand how people cycle through these different work energies, and that's partially why I left in those 3 additional categories that we found, because is that part of the puzzle for how people cycle through these? Is there a pattern to the order of the categories? Do people always hit overextended before you burn out? Or do you even hit all the categories? Or can you go directly from engaged to burned out? And if so, what are the timelines? Can you flip in a week? Can one singular event change that category? Or does it always build up over time? Does it take 6 months? Does it take a year? How fast can people cycle? And how fast can they recover? So I've seen research that it can take people who hit burnout years to recover. And is this always true? Do some people recover faster? And if so, what factors helped them to recover more quickly so that we can use them on other people? Also, in our NLP tracking tool, the next thing that is popped is return to office. And so we'll be looking at that and even starting to combine topics like, how does return to office impact burnout? Do we see that burnout decreases because COVID is waning and is occupying less of a cognitive load on people? Or is connecting with people in person helping people feel a sense of community and belonging to reduce burnout? Or does the added time of a commute and less flexibility lead people to burn out more? What else? We're going to continue to work together to tweak and hone our current models. Our data is interesting as the product, our larger product, is adding functionality in data every day. So for example, we're just launching a new gig worker marketplace. And with it, we would have the ability to study how gig workers are affected by burnout. We also have launched Dayforce Hub, which is basically our client's homepage, but with it, we can dynamically feed clients' knowledge articles. So I can write one-pagers for employees and what to do to feel healthy for each work energy category and put it on their homepage based on what work energy category they fall into at that moment. So we can also feed their managers recommendations of how to improve employee work energy for their employees. By creating these short, tailored snippets, we can make the information relevant and approachable for people when they need it, to nudge them to action.
So in summary, we started our journey with defining the burnout problem, how to measure burnout, and then we had to make sure that we do our due diligence and secure our clients' data. And before we do any ML modeling at all, we had to build clean and scalable data sets. And if you notice, the majority of the data science part of this presentation was about how we built our data set, because we really wanted to focus on building great data sets, not just building ML algorithms. And after we built our data sets, we can create models where we did our experiments with MLflow. And after we created our models, we can generate actionable insights in the form of data visualizations for our clients.
So with that, thank you all for sitting through our presentation today, and we'd love to hear any questions that you have.